Okay. Good evening. Welcome. Thank you for joining us this evening. This is the monthly public meeting of activist meeting of Lower Hudson Group of Sierra Club, which includes Rockland County, but also Westchester, Putnam County, parts of Dutchess County, and parts of Orange County as well. We meet monthly. We focus primarily for many years on the climate crisis, also on water issues, more recently on toxic chemicals and the crisis of extinctions. Our focus has been primarily on state policy and legislation and on local issues that are important to all of us locally. Our focus today is really on New York State, on the retreat from New York State's renewable energy goals, the failure to meet those goals, and the push for nuclear energy. So I want to thank our co-sponsors for this evening's program, that is Grassroots Environmental Education and United for Clean Energy. And we'll start with our speakers, followed by questions and discussion. We'll also have time for other issues following discussion of nuclear energy, and there we'll focus mostly on the local protests against the Trump administration's, I'm sorry to say it, but there's no other way to say it, assault on democracy and on our environment, on the climate, on just about everything that many of us cherish and value. For many of us, we are lucky, in quotation marks, to live in a swing district, Congressman Mike Lawler's district, where we can potentially make a difference. So we'll talk about that. And I also want to talk about, report back on Rockland County's, a recent meeting about why the county has not yet purchased not yet making the transition to electric vehicles. If there are other issues, and we're going to bring up a little bit, do an update, quick update on the Dark Skies Initiative and with the Mario Cuomo Bridge. And if there's anything else I've left out or that you want to bring up, please put it in the chat and we can bring it up later. So now it's my pleasure to introduce our speakers, and we will leave time for questions. I think leave time after both speakers for the questions. Tim Judson is the Executive Director of NIRS, N-I-R-S, the Nuclear Information and Resource Service, and he's been the Executive Director since 2014. He leads their work on nuclear reactor and climate change issues. He's also the chair of the board of the Citizens Awareness Network and co-founder of the Alliance for Green Economy in New York. Mitch Jones is the Managing Director of Advocacy Programs and Policy for Food and Water Watch, and he leads the organization's work on federal and state policy, as well as the organization's political programs. He must be one busy man. uh, we'll start with Tim, and then we'll come to Mitch. Tim, do you want to lead off? I guess I just want to start this by saying, I'm sorry, before you speak, that many scientists and climate advocates believe that some form of nuclear energy will be needed in order to go fast enough and to supply the amount of energy we will need as we electrify more and more things. So, and in the meantime, New York State is failing to meet the mandated timelines for the transition to renewable energy. So that's just a little bit of the background of this program, and I want to just repeat again that all points of view are not only respected but welcomed here. It's the discussion where we really get to, kind of get things to, I think the discussion is extremely important. So Tim, you want to take it away?
Yeah, sure. Thanks, Peggy, and thanks everybody for being here tonight and for having us. So as Peggy mentioned, I'm the executive director of a national organization called the Nuclear Information and Resource Service. But I started doing this work 28 years ago as a grassroots activist where I live in Syracuse. And NEARS was actually one of the first groups that actually helped our local coalition, figure out, what we were really fighting about when we found out about there were serious safety problems at the local nuclear reactors that are 30 miles from where I live here in Syracuse that are on the shore of Lake Ontario. And we founded Agree in 2012 in part in response to a previous push for new nuclear power plants in New York, when there was a proposal to build a third or fourth reactor in Oswego County. Um, and we, realized that we needed to be leading a grassroots transition to renewable energy if we were ever going to be able to fully phase out the dirty and dangerous energy sources that were plaguing our community for so long. And so, I think, but one of the things that I think I want to do tonight is also kind of set all this in some context for folks, because, most of the big fights against nuclear power in New York happened before the fracking crisis really hit in 2008. And so there's a lot of history here. We have a very, very complicated and long history with nuclear energy in New York State. And I think, one of the things that I've been really inspired by in the Hudson Valley is the unity between the anti-fracking movement and the anti-nuclear movement that's evolved over the last 10 or 12 years, that I think is really, hopefully a model for how we can really build a united front, for climate justice and a transition to renewable energy around the country. So with that, I'm going to share some slides and get started. Okay, everybody see that? Great.
Yes.
So get started, I think one of the things that I always start with is, the central question, can we nuke the climate? And the answer to that question is actually, pretty simple. It's no. But of course, there's a lot of reasons for that. And, I think to start with, coming from the community perspective, the reality is that nuclear power is a dirty and dangerous energy source. But it's also from the pragmatic perspective on climate is also too expensive and too slow to make a difference. But with all of that taken into consideration, this is an energy source that is just as much as fossil fuels rooted in environmental racism and human rights violations. Whether it be, with indigenous nations, communities of color, there's a gender discrimination and intergenerational harm. And you can see that if you look at actually the sort of the whole fuel chain of nuclear energy that starts with the mining of uranium, and the whole process of producing nuclear fuel, which produces, by the time any fuel goes into a nuclear reactor, a single pound of nuclear fuel goes into a reactor, every pound of that fuel has produced at least 5,000 pounds of radioactive waste on the front end. And everything, and that all of that fuel that goes into the reactor becomes radioactive waste itself that is toxic for a million years. And also the operation of nuclear reactors produces and releases radioactive waste, both in the local community and in waste that's dumped and deposited elsewhere. So from that perspective, when we're talking about building nuclear power plants, we are talking about putting communities in danger. Now, as I mentioned, we have a very long and difficult history with nuclear power in New York that goes back 80 years to the time of the Manhattan Project. New York had more contaminated Manhattan Project sites than any other state in the country. And then we were also one of the first states where nuclear power plants started to be built in the late 1950s, starting with Indian Point 1, which was built before there were really nuclear safety regulations in this country. And they let that reactor run without any backup safety systems for 12 years. That's how we started with nuclear power in New York, and it didn't really get that much better since then. We've got massive contamination at our nuclear reprocessing site in Western New York. We've had accidents and near accidents at just about every nuclear power plant that's operated in this state. Those communities are suffering from illness, from radioactive pollution, and we have radioactive contamination in our waterways and our land and in the surrounding areas around all of these facilities. And then in addition to that, we've also got a problem with regulatory and political capture of our energy regulators, of the PSC, and of our political establishment that has persisted for a very long time. To give you a sense of where that started, where I'm from, here in central New York, the 9 Mile 1 reactor started to be built in 1965. This is a picture of what that started to look like on the shore of Lake Ontario. And the reality was, everyone says that Oswego County is pro-nuclear and loves nuclear power. But the reality is that when they started to build this first nuclear plant, they didn't tell anyone that it was a nuclear power plant. They just said there was going to be a power plant. and people didn't know. And and if you ask people that were that were alive at the time, whether they were kids or whatever, they'll tell you that that if their parents had known that this was going to be a nuclear power plant, they would have been against it. And and then what's flowed since then has been tragedy and despair from the effect of that. This is me holding basically sort of like a diagram that we made from an old postcard that they used to give out at the information center at 9 Mile Point. That sort of shows actually where all the so some of the history of what's happened there, where the leaks come from, where the radiation is released, where there's safety problems, where there've been accidents, and all of those things. But to kind of step back to where we are now in New York, so now we have an energy crisis that's being used as an excuse to promote nuclear energy, and that's that we're hopelessly out of compliance right now with the CLCPA. We are probably at least if the governor continues on the path that we're on, we're gonna start missing targets under the Climate Leadership Act.
Tim, maybe spell out CLCPA.
Sorry, the Climate Leadership and Community Protection Act, CLCPA, which is our landmark climate law that sets out at least a pathway for us to be able to do what's needed to save a livable climate on this planet. But stepping back to the beginning of where we're coming from in terms of nuclear energy, we have in the U.S. one of the oldest nuclear fleets in the world. At over average age of over 42 years, most of our reactors in the country are over 40 years old now. And in fact, we're getting an increasing number of reactors that are over 50 years old. And in fact, we have two of the three oldest nuclear reactors operating the planet in New York State. And the reason that the reactors are so old is because we stopped building them because it was too expensive and too risky to continue building them. And so what happened in the first generation of nuclear power is that over half of the reactors that were planned were canceled because of cost overruns and delays. And the average cost overruns were over 300% of their original costs. And some exceeded 1,000%. In fact, one of them was 9 Mile Point 2, in New York State, which cost $6.5 billion in the mid 80s to build that reactor. But even then, the delays were also mounting, so that the average construction time for reactors grew to over 14 years. Now what's happened is, the nuclear industry saw that it was going to need to start building reactors again. So so in New York, what this panned out is that we've been bailing out reactors for over 50 years now. So this starting in the 1970s, we were already bailing out Indian Point 3 by having the state take it over from Con Ed. And then that has continued all through the last 50 years. To where, in 2016, the governor pushed through a $7.5 billion bailout of the four reactors in central and western New York. And that included some other bailouts along the way. But about 20 years ago, the industry saw that it was going to need to start building new reactors if it was going to have a future. And so, as part of the big energy legislation that passed under President Bush, there were billions and billions of dollars of direct subsidies. First time that the federal government had directly subsidized nuclear power plants. And this nuclear renaissance was a total failure. Even though there were 30 reactors that were planned, 14 of them actually got licenses to build, but only four of them actually started construction. And those bankrupted Westinghouse, the largest nuclear corporation in the world. And then two of those were canceled. And then the two that were completed were 7 years late and $36 billion in total cost. The ratepayers in Georgia have seen their rates go up by almost 25% as a result of the construction of those two reactors alone. But in the end, the nuclear renaissance had a 93% cancellation rate. So this was the sign that you can't count on nuclear power to help with the climate crisis, because it's going to take too long, and a lot of these projects are going to fail. And then all the effort that you put into it is going to result in more carbon emissions. So that brings us to today. So the industry, after that failure, realized was in a crisis. And so they started talking about building new types of reactors, what they started calling advanced reactors. And so the question is, what is advanced nuclear? And the truth is that there is no consistent definition. This is a term that is flung around to make it seem like there's something new the nuclear industry is offering. But it refers broadly to many different things. So there's new versions of light water reactors like the ones they just built in Georgia. Those are still called advanced reactors. But there's also a whole bunch of other things that really haven't ever been built and commercially successful in the US, what are called non-light water reactors that use different types of coolant besides water. There's small modular reactors, which are supposed to be factory produced in large numbers that can be sent, to a reactor site and assembled and installed. Those can either come in light water reactor flavors or non-light water reactor flavors. And then there's what are called microreactors, which are tiny, relatively tiny reactors that they hope to be able to ship on trucks and trains and deliver by helicopter to remote locations or small communities. But to get a little bit more in detail, so there's several different types of reactors that are embedded in all of this. There's what are called sort of fast neutron or fast spectrum reactors, where they basically don't slow down the neutrons to stop that basically mitigate the chain reaction. These are designed to basically spray neutrons all over the place to be able to either generate more heat or to breed plutonium or in some cases other isotopes of uranium, but basically are breeder reactors. They breed other fissile materials like plutonium. There's the what are more common, which are called thermal neutron moderators, which is where they use the coolant or some other medium to slow neutrons down, which is what a light water reactor does. That's why they use water. But different types of moderators, they can use graphite, which is basically a form of carbon, or heavy water, which is water that's got a heavier isotope of hydrogen that makes the water heavier. There are also different kinds of coolants that can be used in these reactors, including helium, which is used mostly in high temperature gas cooled reactors. Sodium, which is basically a soft metal that's basically heated to turn into a liquid, and these are called liquid metal fast reactors. Sodium is really dangerous because sodium is flammable, extremely flammable. It's also explosive when it comes in contact with water. There's molten salt cooled reactors, which is where they basically use a salt that can be heated to melt, and then the nuclear fuel is incorporated into the molten salt and circulated. And then there's also heavy water reactors, like what I mentioned before as a moderator. There's different forms of fuel that are used in some of these reactors. There's what's called TRISO or pebble bed fuel, which is uranium that's embedded in graphite and then coated in a ceramic. It's sometimes called a pebble bed reactor. There are metallic fuel rods, which are used in fast breeder reactors. There's the more conventional, which is ceramic pellets that are sort of encased in foil to make them into fuel rods. And then there's dissolved fuel, like in the molten salt reactors. And then there are different types of fuel. They're all fissile material, but there's low enriched uranium or LEU, which is what's used in our conventional light water reactors today. They're talking about using a fuel called HALEU, which is uranium that's enriched closer to bomb grade than has been conventional, and really poses both safety risks and criticality risks in its production and transport and storage. There's also what's called mixed oxide fuel, which is where they combine plutonium and uranium into a fuel rod. And then there's what are called thorium reactors, and thorium isn't really a fuel. It's basically they put thorium near a nuclear reaction to breed uranium-233, which is extremely fissile. And so thorium reactors are really uranium-233 breeder reactors. But none of those have operated commercially in the US, and I don't believe anywhere in the world. Um, I can talk more about that if people are interested. But then with all of these reactors, the question is what's going to also happen with the waste? And there was a study produced by professors at Stanford and the University of British Columbia a few years ago that found that this is true, that these types of reactors will produce between 2 and 30 times more radioactive waste by volume than the current types of reactors that we're familiar with. But the reality is that also there's none of these advanced reactors are ready to be built in the US or pretty much anywhere else in the world. All of the reactor designs that are being proposed by a bunch of mostly startup companies that have never built a reactor before, never operated a reactor before, that also none of these reactors have been fully approved. So, this is a list of some of the more prominent, SMR and advanced reactor designs that are talked about. And you see that, almost all of these, either their permits are currently under review, or they've, in the case of the NuScale 50 megawatt reactor, it was partly approved, but with a huge caveat that one of its critical safety components, the steam generators, was not approved for safety. And so they actually abandoned that reactor design and are now trying to get a new version of the reactor approved. Um, and then you have, for instance, Oklo, which is developing a microreactor. Its initial license application was rejected because the application didn't actually include enough material for the NRC to review it. They actually couldn't complete the application, and so the NRC had to reject it. But also the reality is that the cost of these reactors is already skyrocketing. They haven't even built anything yet. And so what you see here is a chart that compares the cost of the Vogtle reactors in Georgia, which I talked about earlier, which started at a cost of $10,000 per kilowatt. And then by the time they were completed, the cost had risen to twice that level. The NuScale X Energy and GE Hitachi reactors are already more expensive than what the Vogtle reactor the cost projections started at when they began construction. So, and in fact, they're already approaching what the final cost of Vogtle was without ever put any even concrete in the ground yet. So with that, there's also been a lot of talk of using nuclear energy to power data centers, artificial intelligence, and other big industrial facilities. Like for instance, the microchip plant that's being proposed for Syracuse. And this is a terrible idea. First of all, it's going to take a decade or more for any new reactors to be built, even if you started today. And they're not waiting to build data centers or these other plants. Those things are going to be built, using whatever other power sources are available. But even if you look at the deals that have been announced, whether it's the deal with Microsoft to restart the 3 Mile Island reactor, or Amazon's proposals for SMRs to power its data centers. None of these involve any significant amount of investment by the tech companies. And in fact, if you ask them, in fact, they're saying it publicly in conferences that I've been to, that the only way that any of this will be done is A, if the nuclear industry can prove that it can actually build projects on time and make them affordable, and B, if the government agrees to pick up the cost of the cost overruns. Now, at the Vogtle project, the cost overrun was $23 billion. So these companies are saying that they are not going to pick up the tab for the failures of the nuclear industry. And if the government wants to build these reactors, it's going to happen at the taxpayers' dime. And that's the same story that we've had for the last 50 years. I think the reality is that we're not going to be able. It's going to be a terrible. It's going to be a terrible plan to invest in nuclear if we're going to solve the climate crisis or power, artificial intelligence. And I'll hand it over to Mitch to give you the rest of that story.
Thank you, Tim. Peggy, did you want to say anything before we move on?
No, no, no. Good. Go ahead. Yeah.
All right, thank you. Thanks, Tim. I always appreciate being on a webinar with Tim. He is my go-to when it comes to nuclear energy. If I ever have a question, Tim's the person I reach out to. So thank you, Tim. I know that we have a time constraint here where there are other issues to discuss. But I want to thank you all for I want to thank Peggy in particular, but thank you all for inviting me to be with you. Mitch Jones with Food and Water Watch. Unfortunately, the light in front of me quality has gone down, so I'm a little blurred, but appreciate being with you. I just want to reiterate a couple of the things that Tim mentioned, and then I think open it up for questions because I have a feeling there probably are several. When it comes to the climate crisis, the idea that nuclear energy is a solution is just patently false. And there are two reasons for this that Tim touched on. First of all, is expense. The fact of the matter is that renewable energy in the form of wind energy and solar, most forms of solar, are already significantly cheaper than nuclear energy is. As Tim pointed out, he showed you those charts of how nuclear energy prices are going up. Renewable prices have been going down over that time. We'll see what the tariffs do with that. But in the meantime, those prices have been going down. So it's actually less expensive for utilities, for energy providers, for consumers to build renewable energy in the form of wind, solar, batteries than it is to produce new nuclear energy. It's cheaper than it is to produce old nuclear energy for that matter. Um, and the other issue is, look, we all know that we have a very limited window to address the climate crisis. Um, there have been some troubling reports I've seen recently that are suggesting that we may already have hit the 1.5-degree limit. And if we haven't, we're hitting it soon. Um, and the fact of the matter is, even if nuclear energy were the panacea for the climate that its supporters suggest, we're talking 10 to 20 to 30 years before a plant gets built. We don't have 10 to 20 to 30 years. We need renewables on the grid now to reduce our reliance on fossil fuels. When you look at the issue of data centers, AI, cryptocurrency, all of those things, which really has become the industry, I think that the nuclear industry has latched onto the idea that we're going to build all of these new AI centers, and then we're going to attach these small modular reactors to them, is one fanciful because, as Tim pointed out, they don't exist. There are three in the world, none of them in the US. They don't exist. It's a fantasy. But two, what it's really doing is allowing for more frack gas to come online. Because while they're telling us, oh, we're going to build small modular nuclear reactors, what's really happening is they're building fracked gas power plants because they can do it more quickly, they can do it cheaper, and they can get it approved and get it online. And so this is just a ruse to cover the expansion of frack gas, which I'm in Maryland. I'm not in New York. I'll just admit, sorry, not in New York. I'm in Maryland, but New York and Maryland, we've banned fracking in both states, thanks to many of you. And we don't need more fracked gas plants, but we have, like you have in New York, where you have legislation pushing more nuclear. Now we have the Trump administration talking about bringing back gas pipelines. Here in Maryland, we've got legislation to push more nuclear and more fracked gas plants. And it's about that AI data center cryptocurrency industry. So we have to push back against that because they're saying they're going to do nuclear. They're not going to be able to do that for at least 20 years.